our data review. So we're going to go all the way back and then kind of work our way forward. So let's see what we got here. Using the data table below, complete the frequency table. Okay, this one, we don't have to worry about order as much. Before we'd had to worry about that, not this time. We just got to make sure we get things in the right spots. So as we cross a number off, ooh, let's see if I have enough room in some of these places. I'm just going to make sure I get them into the right column, because then when I go to do my analysis here with frequency in a minute, I'll actually get the right numbers working here. And again, this takes some more work than some of our other ones does. I guess do would be the correct way of stating that. But it's always good to mark them off as you do them, because otherwise we tend to forget. So we get that set. All right, so we've made it to the end. And for frequency, I'm just wondering, you know, how often in the big picture of things is something going to happen? Well, to understand that, I need to know how many occurrences happened or what my data happens to be. So I can figure out how many numbers I had to work with either by counting up the numbers in the list or just counting up my tally marks. I think the tally marks is faster, so that's the way I'm going to go. I don't think there's any numbers in the... There must not have been any numbers in the list that were between 21 and 25. Yep, we're just marking them off as we go. So let's make sure we got the right number of numbers here. I'm going to kind of double check. I'm going to check my list here quick. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, I counted 23 numbers. Hopefully my tallies add up to 23. 8 and 3 is 11, and 4 is 15, 17, and 6 is 23. Awesome. All right, so my frequency is just making a fraction out of this. So 8 out of 23 would be 11 through 15. 3 out of 23 would be my values from 16 to 20. And as has been made mention of already, I actually have 0 in one of my categories. So if I were making a graph, there'd be a gap in there. 26 to 30, there's 4 of them. And then there's 2. And then there's 6. Okay, so when I'm making a frequency table, that's all I'd have to do. And if I were graphing this, these would be on my x-axis. I'd have all my numbers, and then my frequencies would be my bars that were going up. So, again, something to just kind of get you ready with bits and pieces, so we don't have to go and overkill on drawing everything necessarily. Let's see here, number 2. Test scores for 10 students in Ms. Sampson's homework were 61, 67, 81, 83, 87, 88, 89, 90, 98, and 100. Not bad. Which frequency table is accurate for this set of data? Well, let's see. Where are the differences at? We're a little here, we're a little there with everything. So let's see. How many of each type have we got here? At least they're in order for me. So how many actually are there in my list that are between 61 and 70? 2. Okay. Oh, they all have 2. Heck. All right. What about 71 to 80? None. So which 2 letters does that cancel out? Okay. A and C are gone because they have frequencies that aren't 0. So there they go. What about 81 to 90? I think it's B. Well, let's see. 81 to 90, how many of those have we got? 6 of them. D says there's 8. That doesn't work. So, yep, correctamundo on B. So nicely done. All right, flipping over. All right. Our graph here shows the distribution of scores of students, 30 students on a math test. So we had a gap here, and then we've got some scores in the places. Complete the frequency table using the data in the frequency histogram shown. Okay. How many people took the test? 30. Okay. So we're going to have fractions that are out of 30. So we'll start at the top here. How many scored between 91 and 100? 2. But can I reduce the fraction 2 out of 30? If you're not sure, let the calculator help. 2 divided by 30, math, enter, enter. Looks like 1 over 15. And yes, we need to reduce it to its simplest form.
That confuses me. I like doing 2 over 30 better.
What's that?
I like doing the 2 over 30 better, because the 1 and 15 would be 15.
Okay, but that would be the same thing as if you were doing like on a standardized test and you were checking out something that said like 5 out of 10. 5 out of 10 won't show up in the answers. 1/2 will. So it's just one of those things I'm trying to get some of you thinking as it gets towards... Right, because 2 can divide into each of these. So 2 divided by 2. That's why I just did it on the calculator and let it help me.
What if they all don't end in 15?
That's okay. Yeah, they may not end up at the end all ending in the same number. That's a good point.
I know, but that would be like more difficult to find out. I don't know.
No, but I do. I get what you're saying because it would be easier to look at when you're looking at comparisons with all the numbers on the bottom, with all your denominators being the same, and that's true. But like I said, the big thing I'm doing here is trying to help and prep some of you when it's getting into kind of standardized testing here in the next month or so. And what'll happen is if you had a question like, what was the frequency of students scoring between 91 and 100, 2 out of 30 will not come up as the answer. It would come up this way. So I'm just kind of trying to get you to be able to see it that way and think like, oh, I got the right answer. I just got to reduce it a little bit. Like, for instance, what about 81 to 90? How many do I have? 8. But again, I've got something that divides into both of those. So 8 out of 30, I can divide each of those by 2. So I end up with 4 out of 15. What about 71 to 80? 12. You'll never guess. I think it reduces. Whoops, I hit the wrong button. 12 divided by 30, not just 12/30. They're like, oh, now it's changing fractions again. Now it's 2 out of 5. 61 to 70? Zippo. Nada. You can put that over any number you want because it's still 0. 51 to 60? 5. Let's see if that reduces down. Pretty sure it does. 1/6, uh-huh. And 41 to 50, that's unfortunate. 3. 3 out of 30 goes down to 1/10. Okay. So if you want to find the frequencies first over 30 like we did here, that's fine. But once you've done that, then you do need to go through and reduce those. Okay, so we'd have answers that would be similar if we were doing it on that. And we finally get to do a graph. So here's these scores on a math test. Complete the table, use the table to construct a frequency histogram for the scores. Okay, so we got to go back through again and make our tallies so we can create our frequencies. Ouch on the 40. So I'm just filling in my tallies. And then I'm just going to make sure I did everything right. I want to make sure I have as many tally marks as I do scores. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scores. 1, 2, 5, 8, 11 scores. Okay. So my frequency histogram, I'm going to go ahead, I'm going to get my fractions in here. But when I go to make my bars, I'll use all the whole numbers. So 1 out of 11, 1 out of 11, 3 out of 11. Oh, the rest of them are all 3 out of 11s. And none of them reduce any further. And if I wasn't sure, I can still check. I could do 3 divided by 11, math, enter, enter. It just doesn't change anything, okay? So when I go to do this, you can do it a couple of ways. If you don't like the bars being so skinny, you absolutely have the choice of extending them more. Sort of like if you notice up above here, okay, they kind of went double or even triple wide sometimes so you can see. So I think double wide's not a bad idea, so I'm going to skip one. We'll have 40 to 49 in here. But once you start, you don't want to have gaps in places. And we usually just leave that gap in at the start to signify that we're kind of starting not at 0, but a little beyond that. So when I get these in, and we like to label our axes so we know what's going on here. So these are the actual scores. And then the number of tests with those scores that go up the side. Because if somebody came up and looked at this, we want them to know what it is. If we just show numbers, I mean, it could be scores, it could be, I don't know, pulse rates, it could be anything. And I'll notice here, these aren't going to be incredibly tall because, again, it's anywhere between 1 and 3. So maybe to make things taller, maybe I do every other line is 1. But if you did it 0, 1, 2, 3 with the first 3 lines, that's okay too. Okay, you've got some flexibility with these. So once I get here, now I just go and I start looking and I say, okay, so from 40 to 49, I only had 1. All right. Maybe I'll just use some different designs so people can tell. Tests, number of tests. So 50 to 59, there's only 1. Okay, maybe I'll shade differently, maybe I'll have different colors, maybe like for 60 to 69, maybe I'll decide I want to use dots instead. Kind of show some things differently. 70 to 79, I had 3. Oh, let's do stars this time. And 80 to 89, there's 3. I'll just color this one in fully. And that would be my histogram for this. Basically, it's a bar graph, but it's a bar graph based on how many total scores there were. So it's based on 11 students. And most of the time with that, you'd probably have that listed somewhere within what you were doing. So that basically works us through our first part of things. When we were doing all the things with the bars and the histograms, we got a little more coming with these. All right. Let's see what else we got working here. Which of the following histograms represents the data below? All right, let's see here. Okay, our interval from 4 to 8, there's 8 of them. Does that eliminate any of our choices? Between 4 and 8, there's 8 of them. Look at the graphs down below from 4 to 8. Which ones don't have an 8 in 4 to 8? We're just looking at this bar. Which bars do not go up to 8? B does not go up to 8, okay? A, I agree, it only goes up to 5. And C only goes up to 7. Well, woohoo, I don't even have to look at anything else. I'm done. Okay, good test-taking strategy. I don't necessarily have to look at every single one if the first one eliminates 3 out of the 4 for me. That's kind of nice. So I just say, good, I'm done. I'm going to the next one. I won't do every one of the graph ones with you, but this one's a little bit different again. So I want to make sure that we knock this one out. All right, the following data here consists of the weights in pounds of 24 high school students. Using the data, complete the accompanying cumulative frequency table and construct a cumulative frequency histogram. Now, it's really not any different from what we've been doing, except for we're going to mark these people off. And our frequency, we're going to use kind of like we did our tally before. And again, we're going to get a general idea on the weight class of students that I'm assuming probably they're in an individual class here. We can start making some assumptions on build and weights, and maybe check that into some other things as they're doing some of the activities that they do. Some of them are right on the borderline here too with some of the weight classes. The nice thing this time is, at least they tell us how many students there are, so I don't have to worry about going back and having to count all that up. Because I look and I'm like, okay, 6 and 7 is 13, and 6 is 19, and 5 is 24. And I already know there's 24 total, so I'm feeling good here. So I know that. And then my cumulative frequency, like we did before, is just making a fraction out of this. So once I get my frequencies written down, so 6 out of 24, 7 out of 24, 6 out of 24, 5 out of 24, 2 of those reduce, the 6 over 24s. So if I were to punch those in my calculator and do a math enter, I get 1/4 out of there. But the other ones just stay the way they are. But when I get to my table, what might be a good label for my x-axis down here where I'm going to be putting these numbers? Look in your original problem. What would be a good label? Weight. Good enough. Are we weighing them in kilograms? Pounds. Okay. Weight in pounds. Okay. So again, and since we're doing it in intervals, we'd want to go ahead and label those, and I'm going to do them too wide here again. And since my frequencies are anywhere between 5 and 7, now I cannot start the bottom line at 5, unless I was counting by 5s. So if I wanted to, I want to spread it out a little more here again. I'm going to go every other line, but I'm still only going to count by 1s. Because I've got plenty of room to work with. I mean, if you really wanted to go every single line's 1, you could. And then again, you're just going up as high as each of those go. And again, either different shadings or a scribble or a design or something just to make it a little bit easier to tell. And I'd see that my data is pretty well distributed. I have a few less people in the heavyweight range here, and a few more in that mid-range. But again, you'd be able to quickly look, instead of looking at this big old long list, just look at this chart and go, yeah, it's pretty well evenly distributed over all the students in this particular class. So again, nothing too bad going on here. But again, it's just the time consumption in looking at the data and putting it into something, into a form that's actually useful. That can take a little bit longer. All right, let's keep floating along here. I'm going to go past number 7 for right now because it's just another one of the frequency graphs. I think we've played enough with those to make that pretty easy to work with. Okay, 8, they got a picture of one of our types of plots we've been doing. Which one is that? Yeah, that's a box and whisker. Because bar and histograms are basically what we've been doing before, and stem and leaf are those ones where you've got something that looks like this, and you get the first number, and then the rest of the numbers are after it. But yeah, box and whiskers are a pretty obvious one. All right, so number 9. Now we're going to have a little work here. It doesn't seem like there'd be much work with a multiple choice, but there is a little. For us to be able to figure out our mean and our first and third quartiles and our extremes and stuff, we have to put the numbers in order. Somebody's been listening. This is good. All right, so let's see here. What are we starting with here? 8. And 9. Got to keep an eye on me. I'm known to skip numbers. 10. 15. 2 16s. 2 19s. 20, 21, 22. Okay. Once we have them in order, now we could go find our median, and that might even be enough to get us the information that we need so we can be done with this one. So I start working my way towards the middle. Let me do that again, because I'm not getting the same thing. All right, let me start working in. Okay, 16 is my median. All right, let's see if we have multiples. Oh, bummer. Did any of them not have 16 as a median? Here's my median line on all of them. Do any of...
I think A is 17.
I agree. A is at 17. Okay, it's not A. So let's see. Now let's look at our extremes. Maybe that'll help us with something. So my lower extreme is 8. My upper extreme is 22. So that, of course, again, is going to be my little... I'm being told it's C. All right, let's see. Let's see. 22 and 8. Okay, D would still be okay here. 9, 8, 20, 21, 22. C is still okay. Well, God, they're not going to eliminate any of them. Okay, that didn't help me. So again, it's going to come down to our quartile measurements. So I look at this and I go, okay, again, if there's only one median number, I don't use that. And I work to the middle. So my Q1 would be 10.
It's C.
And I'm being told it is C again. Let's check this out. Q1 of 10, yes. Q3 of 20, yes. I agree, I agree. It is C, it is C. It just took a little time to get there. All right, over we go. Construct a box, and oops, helps if I have that on the screen. Construct a box and whisker using the following. Let's do this. Were they nice and put them in order for us? Heck no. Okay. Well, we can take care of that. Where's my smallest number?
It's 12.
It's 12, and I got 2 of those. All right. So 2 12s, a 13, looks like a couple of 14s, and a 15, Ooh, lots of 15s. 3 15s. 2 16s. And a 17. And an 18. And a 20. All right.
Hey, can your box be underneath the graph?
Yeah, that's okay. Yeah, if you've drawn it away where you need to label above it and have the box under it, that's okay. So, all right, median. In we come. In we come. All right. Looks like my median here is at 15. Which means I do not use that for either of my Q1 or Q3 jobs here. Let's see. All right. Oh, 2 numbers in the middle this time.
13.
Yes. I add those 2 numbers up, the 13 and the 14, and divide them by 2, which would be 13.5, which would be my lower quartile or my Q1. And then I do the same thing over here. Again, I end up with 2 numbers in the middle. 16 and 17, add them up and divide by 2. Gets me my 3rd quartile. And then, of course, I have my extremes being my least and my greatest number at the ends. So again, I get my number line working. And I notice this sucker goes from 12 to 20. I'm just going to start at 10. And you can number every single line if you want to. I'm just going to label every 5th one. I'm going to label the ends in the middle. Want to have the same value for each one, though. We don't want to skip around. And once I get there, make myself the median, my 1st quartile, my 3rd quartile. Okay, so there's my box. And then my whiskers, and you can use lines for these too if you want to. Just connect to my box and I am good to go. Now, one thing I am going to ask, what percentage part of my data is in each part of this again? There's 4 parts. So if there's 100% total and it's divided evenly into 4 parts, how much does each part represent? 25%.
Yeah.
So no matter if it's a really big piece or a really little piece, 25% of my data is going to be there. And that's going to be important as we get to this next part. So we're going to try to get to the bottom of this page. I think we're going to get there. All right, the accompanying box and whisker represents the scores earned on a science test. There they are. I'm going to go ahead and label the parts just so if I'm looking for something I can find it quickly. So according to our diagram, what is the median score for the test? 75, because I labeled it. It's right there. Boom. Okay, let's see. According to the diagram, what score represents the 1st quartile? 70. Because again, it's that first line in my box. Okay, let's see. 13. What statement is not true about the box and whisker plot shown? 75 represents the mean. That's true because I can't figure out the mean from a box plot. That's my problem. As soon as you see the word mean with box and whisker, it's not happening. So good call on that one right away. Score of 85 refers to what? Find 85. 3rd quartile. Yep, letter A. Good. And finally, down here on the bottom, and then we'll be set for the day, Arrange the following data from least to greatest and find the mean. All right, I can do that. So I know it says find the median of the upper and lower halves, but we need to find the regular one here first. 21. Find the median of the upper half of the data. This isn't going to be too bad. Wait a minute. What did I just do? Can somebody tell me what silly thing I just did? No.
20 and a half.
Yeah, how many numbers are on each side? Hardy, you goofball. All right. Am I allowed to say here, I was just checking to see if you were paying attention? No. All right, let's do this again. 2 middle numbers. Add them up and divide by 2. That's better. My median's 20.5. Now I can figure out the other parts. All right, let's see here. Median of the upper half. What's my median of the upper half going to be? What number's in the middle of what I've underlined in blue?
44.25. I don't have a calculator, so I can't find
Nicely done. He didn't even let me fool in there. I actually tried to that time and I was unsuccessful. If my median covers 2 numbers, got to use both. So I got to add up 24 and 25 and divide it by 2. 24.5 is called my third quadrant, or my upper. So then, what about the lower? Add them up and divide by 2. 18 and a half, 18.5, and that is my Q1. If you want to keep plugging along right now, you can, but that's as far as